Hi and welcome to Module 11. In this module, we're going to visualize the landslide that happened in Gjerdrum, and we're going to use some elevation data from høydedata.no in the area, which is shown in the figure here. And this landslide happened on December 30th of 2020, and it was a quick clay landslide. 10 people actually died and 1,600 people got evacuated. It happened during the night, and once we got these elevation data, it's all in GeoTIFF files. So we actually have to download the GeoTIFF library to proceed using these files. So in this cell here, you have to run this before you run the next cell to make sure that you have installed the GeoTIFF library. We have already run it because it takes a while and it's already installed in our notebook, but let's run it again. So in the next code cell here, you can see that we're importing the necessary libraries that we need. It's all libraries that you've used before except the GeoTIFF library and the Plotly library, which is a library that's similar to matplotlib, but you can do a little bit different models with 3D models and stuff. So it's really cool. You'll see later on. So now we're going to go through the elevation profiles from the years of 2007, 2013, 2015, 2020, and 2021. So these are all the TIFF files we've gotten from høydedata. So first we've created a subplot, and this is so it's easy to visualize them all together and compare them. And then we have created the first subplot, which is the year of 2007, and we've read in or loaded in the GeoTIFF file, and then created an array for the y-axis points and the x-axis points. And then we've created a mesh grid for the x and y coordinates and defined the contour levels as sea levels. And then when we want to plot the 2007 data, we create a variable, CS, and here we put in where on the subplot we want it to be. So we want it to be the first subplot, so it's 0, 0. And then contour f is a function from the matplotlib library for drawing contours. And then our x coordinates, our y coordinates, our array from 2007. And then our color map is terrain. And then we set our levels to sea levels, which we created earlier. And then as you can see here, we've just set where we want the color bars to be, and the label. We've set the title, Y label, the limits, and scaled it as well. And for all the other years, we've done exactly the same, except we've of course used the TIFF files for the different years. So let's run this code. Because it's a bigger code, it actually takes some time before it runs and shows. So it depends on your computer if you have enough power in your computer for it to be able to run it fast. So here we have it finally. And as you can see here, it's very minor differences in the first 4 plots. But in plot 2021, you can actually see really clearly where the landslide happened, which is very cool.
Okay, so for now we will continue with the 3D model. With the 2D model we can observe some changes in elevation, but also we can check that on the 3D model. We will try to use the Plotly library. We could also use a matplotlib library, the previous library that we used. But Plotly has more capabilities and functions, so we can play more interactively with the 3D model. If you don't have a Plotly installed library, you need to run this code. We already run the code, and I will just show you the code, because if I will run it, will take some time for generating 3D model. So this time we will try to use the function, because previously, as you saw, we used the code and we were just repeating the code of lines of code for each year. In opposite side, we can do just function, so we just recall it and give other inputs that we want to, and then just produce the model that we want. In our case, so 3D model, we use this define function command name, and then the parameters that we're gonna pass later. So that's the file name. It will be our different GeoTIFF files, annual GeoTIFF files, and then a title, the name which we want to have on our 3D model. So here we put the DEM surface, our GeoTIFF, and the file name that we gonna use. So it's here, the parameter. Then we put the array. It's gonna be array of just a separate values from our GeoTIFF file, and then we initiate the y and x coordinates from array that we have here. Then we create the surface plot, so it will be a 3D model. Plotly library, it has slightly different syntaxes rather than the matplotlib. You can check the library in their official website for documentation. So it has different kind of functions. So here we call our library, we name it GO. So we call a library, then dot, we call a function figure, which gonna create some kind of figure. We choose a surface, so it will be the 3D model in a function surface. We put different inputs, so it will be z, x, and y data. Then we set the color scale, which is jet. So Plotly has slightly different color bars comparing to Matplotlib. So in our case, we will use a similar color bar with similar color sequences. Then we choose the range for the color scale, so the Cmin and Cmax. And then for the color bar, we can also control the thickness, the position, and the length also of the color bar. And then having this Plotly library and its commands, we also put the update for the layout, how we're gonna have the figure set in the layout, the width, the length, margin, and all this stuff. Also here we control the z-axis and the aspect ratio, how it's gonna show up in a final plot. And then we just return the final figure, so it will show up after all the lines of code will run. Then, as we discussed, we will just put the different years and use just functions. So we'll call the function and we will pass different TIFF files and, of course, the titles. So here we're just gonna show the 2021 year data. So this is the year where we saw the changes in 2D plot. So here the main landslide took place. So we initiate, we create a variable, we recall the function that we created, so create 3D plot, this one function, and then we just pass the parameters that the function needs. So that's the annual data and the title, and then we just show the our figure. So here we see this 3D model that was generated. That's the done with Plotly, and here, as you can observe, you can play with this 3D model. It's interactive, and you can zoom in, zoom out. So that's the most notable, you see, changes in a topography. So that's the place where the landslide took place, and here also the bar that we created. So then we can also plot the difference in elevation. So we can kind of do the subtraction for each year of elevations. And we will do it in the same way as we did previously with the function. So this time we will create the separate variables that will contain those differences in separate variables. So here what we do, we took the annual array, for example, 2013 minus array 2007. So it will be the operation of array subtraction in Python. And then, as we did previously, we will create the subplots as we did previously for the 2D plots. The same way, but with a matplotlib, and the same workflow for the function. So we call the function, initiate the creation process, name it, give parameters for inputs. We generate the y-x axis, and then we put the contour levels, draw the field contours with the color map. In this case, we're gonna use BWR color map in Matplotlib. So we also can check different color maps in their documentation. And then we put the color bar, we set the title, we label the X and Y axis, and also we invert the Y axis because GeoTIFF has inverted axis. And then we put the equal scaling for both X and Y axis. The same way we did previously, we call the function, we put the inputs required for the subplots, and then we put everything together in one plot. So here you can see the different maps for difference in elevation between the years. So if you remember, our landslide took place in the end of 2020 year. So following the plot from 2007, we see some changes, and the color bar, as long as it's a difference between elevation, minus values will show that there will be some changes in elevation, negative elevation, so it will be a landslide or some erosion processes. And then the positive values, it means that we got some additional land or rock or something moved to the place. So something like here also may be caused by landslide or maybe some construction work or whatsoever. And then we see that there wasn't really big changes in topography. And then between the years 2020 and 2021, we see those massive changes in topography. So that's exactly the effect of landslide that we observe. And then we also can try to see those changes of elevation in a 3D model the same way we did. Use the function. We create here our function, all the code. We use this time the parameters as X and Y and title. Then we create a custom color scale because this time as well we're gonna use Plotly for the 3D model. Plotly doesn't have the same color bar as in Matplotlib, so this one. So we can create our own custom color bar. So we initiated by creating the variable maximum absolute value for normalization. So we will be able to normalize the data and use it properly. And then we put this color scale dictionary, array. So we will use the blue and red and the white color for the values of 0. So everything we do here, all the operations. And then for the red values of maximum, we're gonna use this. And then the same way we create the surface plot as we did previously. We use the this function figure. We use the surface function to generate a 3D surface, and then all the parameters that we use, Z values, X and Y, the color scale. Here we use for this time our custom color scale, so it's this one that we created. And then the same for adjusting the thickness and all the positional parameters for the plot. And then the same way we normalize and put the width and margin. And then for each year, you can play with it and just uncomment this code to generate different year plots. And then for the year 2021, we generate this 3D plot. So here, as you can see, it takes some time because it's a 3D model and it's pretty demanding model maybe for a computer. So yes, as you can see, that's the main location where the landslide took place. So we have a positive values where we have the landslide mass moved after the initiation process, and then the negative values. So that's the place where the old location of the point where the landslide started to take place. You also can check the report, which states the main reasons behind in terms of geology and engineering geology related to erosion and the uplift in the area, which was the main reasons for taking place of the landslide in this case. So good luck and try to play with this notebook. Have a nice day.